For our next example of using double and half angle formulas to simplify trig expressions, we have simplify the following: negative square root of 1 minus cosine of x minus 1, all divided by 2 inside the radical. So again, you might be wondering, how do I know when to use double and half angle formulas? Well, this looks a whole lot like a half angle formula. And the reason I say that is if we go back and we look at our half angle formulas, we have a 1 minus cosine over 2 and a 1 plus cosine over 2. Inside of radicals, of course, there's a plus or minus there. So it looks a lot like a half angle formula. You're probably going to end up using half angle. So how do we simplify this? Well, we're going to use the same 3 steps we used before in order to simplify this expression. So step 1, we're going to simplify the trig expression using basically any method we've learned before, okay? All the way from Pythagorean identities to factoring to, in this particular case, we're going to use some substitution, meaning, here's the problem, right? Inside of these parentheses we have x minus 1, and that, we can't have that for a half angle formula, right? It's just a single variable in there, theta, or you could say x, it doesn't matter. So the point is that we've got to get it to look like one of these, and right now it doesn't. So we're going to just change that variable to that x minus 1. We're going to call it u, okay? You learn in calculus that u substitution is very, very popular. For whatever reason we use the variable u. You can use any variable you like. So anyway, since u is equal to x minus 1, we're going to replace the x minus 1 that we originally had with u. So now we have negative square root of 1 minus cosine of u over 2. Pretty simple, and in fact, if you look at the formulas we learned, it looks a lot like the top one. It looks like sine of theta over 2, right? I mean, it's very much similar. There's really not a whole lot going on in this example, actually. It's really easy. So now that we've established that it looks a lot like that one, let's move on to the next step. Again, I said step 2 was to write it in terms of one trig function. And guess what? It already is. It's already in terms of cosine. So there's really not a whole lot to do for step 2 other than to check it off and then say, yeah, it's in terms of cosine, we're good. Step 3 is to write the expression in terms of a double or half angle. So again, if we go back and look at that formula, we can see that the plus or minus the square root of 1 minus cosine theta over 2 is equal to sine of theta over 2. So the only difference is we have the variable theta instead of u, so this is just going to become sine of u over 2. So that's exactly what we're going to replace it with, sine of u over 2. Now finally we said originally when we did some substitution, we said that u was equal to x minus 1. So what we're going to do is replace the u with x minus 1, since that's what it equals, and that's basically going to be our final answer, sine of x minus 1 over 2. So to reiterate, we started out with negative square root of 1 minus cosine of x minus 1 over 2. The final answer is sine of x minus 1 over 2. Without using variable substitution, you could have just seen that this x minus 1 basically goes in place of the theta, since it's there. And it looks just like this formula right here, except instead of a theta, there's an x minus 2 there. So it's just applying that half angle formula. That's it for this particular example. If you have any other questions about it, let me know.